Hello everybody, welcome to Simplified in 5. Today we are going to talk about weak underscore PTR provided by STL. So let's see what is the weakness of this weak pointer. So basically weak underscore PTR is a template class for an object that points to a resource that's managed by one or more other shared pointer objects. So weak PTR will itself will not be completely managing life cycle, won't be completely managing life cycle of any resource. So it basically points to a resource that is managed by another shared pointer object, and that's why the weak PTR object uh, doesn't affect resources reference count. So the last shared pointer object that is managing the resource, if that gets destroyed, the resource will be freed. Um, and even if there are weak PTR objects pointing to that resource, the resource will get freed. Okay. So moving on, let's see what are the five key things about the weak pointer. So basically, weak PTR creates a weak link to the resource and don't control the life cycle of the resource, as we saw. Then it's basically very much useful to avoid cycles in data structures. We can make use of the expired function to find out if the resource is destroyed or not. We can make use of the lock function to get the access to the shared pointer which is holding the resource. So weak PTR object doesn't provide direct access to the resource. You have to make use of lock function that will give you the shared pointer, and then you have to access the resource through that shared pointer. Then like shared pointer, you can also make use of the use count function, which will tell you the number of shared pointer objects holding that resource. Let's try to understand these things with simple example. So weak PTR, to use weak PTR you have to hash include the memory header. So let's say we created one pointer called as pointer 1, and then in a different scope, let's say we are making use of it. So if I create a shared pointer uh, sp1 and initialize it with 10, now I can initialize my weak pointer with the shared pointer. So now weak pointer as well as the shared pointer 1, both of them will be pointing to uh, 10, and they will be, whereas shared pointer will be managing the life cycle of the integer. Weak pointer will be just pointing to it. Now similarly, if I create another shared pointer sp2 with the help of sp1, now when I check the use count for my weak pointer, I will get 2, because now two shared pointers are managing the life cycle of the resource. Similarly, if I want to get the access of resource which is pointed to by weak pointer, I will have to make use of lock function. So this lock function will return me the shared pointer, and then I have to make use of the dereferencing operator to get value hold by shared pointer. Now once the scope is over, the shared PTRs sp1 and sp2 will go out of scope, and WP1 will get expired. So we can make use of the expired function to find out if the resource pointed by WP1 is still alive or not. So this is a very basic example for weak PTR. We also saw the five key things about weak PTR, and we also understood why it's called as weak PTR, although it's a very smart pointer. So thanks for watching and hope this helps.